Sarthak! Where are you?
Lieutenant! I'm here! Lieutenant!
Come on, it's time to go. I don't want to stay behind. Come on. Come on. I'm getting to the back. Come on, Lieutenant. I don't think I can go any further. You gotta keep going. Tell my family I love them. No, stop that crap. You come with me. I told you off, you're gonna come with me. Come on. You're almost over there. Come on. Come on, Private! Right here. Over there. Just for a second. I gotta save you. Stay over here. It's time to go home, buddy.
Wake up. It's not time yet. You need to stay here.
Well, my friend!
No! No! Lieutenant!
Lieutenant Paulo saved my life in the woods that day. By launching a Coca-Cola flare, he sent out a signal to the nearby camp, and soon they came and rescued me. The war ended 3 years ago, but Lieutenant Paulo's life ended that day, and I will forever be grateful for what he did for me.
Alright guys, now that we've watched the movie Saving Private Sarthak, it's time to take a look at the mathematical concepts within the movie. So in the first problem, there's a wounded soldier who weighs 10 meters away from a Coca-Cola rocket launch site. If the speed of the rocket is 2 meters per second, then how fast is the distance between the rocket and the wounded soldier changing when the height of the rocket is 6 meters? So after looking at our problem, it can be interpreted as a right triangle, and we can find some of the givens and what we need to find in the problem. So one of the given values is that the soldier is 10 meters away from the Coca-Cola launcher, making x equal to 10 meters. Next, we know that we're trying to find the rate and change of z when the rocket is at 6 meters, so our y will equal 6 meters. Then we are given that the rocket moves at a rate of 2 meters per second. So this is meaning our dy dt equals 2 meters per second. What is unknown in this problem is the value of z and dz dt, which is what we are trying to find in the end of the problem. The first step in this problem will be finding z, the value of z. And we can do this by plugging in the known values into the Pythagorean theorem. So the Pythagorean theorem states that x squared plus y squared equals z squared. Our x and y values are given. X equals 10 and y equals 6. 10 squared is 100 and 6 squared is 36, and we know this equals 136 equals z squared. Then we must take the square root of both sides, which will equal square root of 136 equals z, and the square root of 136 is approximately equal to 11.662. So now that we have our z value, we can find dz dt. Again, using the Pythagorean theorem, x squared plus y squared equals z squared. We take the derivatives of the equation, and that comes out to be 2x dx dt plus 2y dy dt equals 2z dz dt. So next, we can plug in some of our known values in this equation, and also what we know is that since the distance between the wounded soldier and the Coca-Cola launcher in terms of x is never changing, it's always going to remain as 10, we can consider this to be 0. So 0 plus, we know 2, because that's part of the derivative, our y value is 6, and our dy dt, the speed of the Coca-Cola launcher, is 2. Equals, we know our z value, which is 11.662, so 2, 11.662 dz dt. Next, if we multiply those out, it comes out to be 24 equals 23.324 dz dt. Divide each side by 23.324. And your final answer comes out to be dz dt equals 1.029 meters per second. In problem number 2, a wounded soldier weighs 10 meters away from a Coca-Cola rocket launch site. The bottle blasts off and maintains a velocity of 2 meters per second. Assuming the scenario can be modeled as a right triangle, how fast is the angle of elevation changing in radians per second from the wounded soldier to the Coca-Cola rocket at 15 meters from the ground? So just as in the previous problem, this can be interpreted as a right triangle, and we know some of the values which are given to us. So the first value is 10 meters. That's the value that the wounded soldier weighs from the Coca-Cola launch site, so that makes x equals 10 meters. Next, we know that y equals 15 meters because we're trying to find the rate and change of theta when the height of the launcher is 15 meters, so y equals 15 meters. And lastly, the last thing we know is that the speed of the rocket launcher is 2 meters per second, making our dy dt equal to 2 meters per second. And what we're trying to find in this equation is obviously d theta dt. And to find that, we'll also need to find our z value. So similar to what we did in the previous problem, we'll need to use the Pythagorean theorem to find z again. So the Pythagorean theorem states x squared plus y squared equals z squared. Our x value in this problem is 10, so 10 squared plus our y value, which is 15 squared, equals our unknown z squared. This equals 100 plus 225, which equals z squared. This equals 325 equals z squared. So we take the square root of 325, take the square root of both sides actually. Squared, and so our z value is equal to 18.028. So to find d theta dt, we're going to have to use the tangent property, which states that tangent of theta equals opposite over adjacent. In this case, our tangent is y over 10. So next what we're going to have to do is take the derivative of this equation, and that comes out to be secant squared theta d theta dt equals, when we're going to have to do the quotient rule using this, so y 10, so derivative of y is 1, derivative of 10 is 0, multiply those out, that's 0 times 10, so 10 over 10 squared, which equals 10 over 100, which equals 1 over 10. So we're going to have to plug in 1 over 10 back here, dy dt. So our next step after that is to plug in our values, which we can use for this. So that would be, as we found our z value, it would be 18.028 over 10, that's in parentheses, squared d theta dt, because that's what we're still finding, equals 1 over 10 multiplied by our dy dt, which is the speed of the launcher, which is 2 meters per second. So to simplify this, we get our equation to be 325.009 over 100 d theta dt equals 2 over 10. After this, we can kind of flip them and get this onto the other side. So essentially what we would have is d theta dt equals 2 over 10 times 100 over 325.009, and this would be flipped because now we're multiplying by them, so we just divided, and then we would have to multiply by the reciprocal. And then after that, what would go on to happen is we multiply this by 10, so that equals 200 over 3,250.09, which approximately gets us to 0.0615 radians per second, and that is our d theta dt. What did I say? Action, bro! What is so hard about that? Oh my god, bro! I recorded that whole scene as well.
Oh, my friend!
Ah!
Go, 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 go! Go, go, go! Go! Farewell, my friend! No! Farewell, my friend!
Stop!
Turn around, turn around, turn around. Turn around, like flip it over, flip it over. Yeah, because you want to get the Mentos in there.
Okay, we
Let
get.
it build up, let it build up.
Yeah, you can start the video. Yo, touch this.
Come on, bro! The video's going!
No, 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 just launch it. Be good.